Okay, EPRI announced a collaboration with, I think it's Prologis, NVIDIA, and InfraPartners in terms of studying smaller scale data centers designed for distributed inference. Please, can we have a little bit of background on the project, how it came about, what it's exactly planned to do?
Yeah, absolutely. Thanks for having us on. And the whole purpose of sort of our micro data center sort of distributed inference project really kind of came about, just the idea that, we've seen lots of development of these big data centers, right, for the development of these AI models. But really, like we've got another compute wave coming to understand, how we're actually going to use all these wonderful tools and use cases and things, and our real-time translation on our AirPods and our Meta glasses and our Chat GPT and everything. And so understanding opportunities to meet the demand for the compute for those, that distributed inference for using those AI models is something that we saw coming as we worked with the tech partners and everything sort of out of, the understanding of the big data centers. So that was really sort of the genesis was like, hey, we've got to use these AI models. What can we do to get ahead of it? And then sort of came around, where's the low-hanging fruit? Where can we actually go out and find opportunities for speed to power because we don't want to wait 7 years for all these great things. And so that's when we started looking at, is there opportunity if we start looking at like the distribution level at substations and things where you have these substations that have excess capacity because they are underutilized, can we actually make use of existing assets and pair that with a data center for inference and really sort of have a win-win, provide that speed to power to the technology partners and at the same time make better use an asset from the utility side. So that was really sort of the genesis, and then our CEO Arshad Mansour helped make a bunch of great connections, including with the great folks over at InfraPartners and NVIDIA and Prologis, and it's just been we've been off to the races trying to accomplish this because I think there's a lot of great work that we can be doing here.
Just to quickly add to that, the partnership between EPRI, Prologis, InfraPartners, and NVIDIA is unique because it brings together key partners. So EPRI provide the power research, knowledge, power availability. Prologis, real estate, land experts know where those land pockets are and what's feasible on those lands. InfraPartners, we provide the data center design, build, and the supply chain. And NVIDIA bring together with the GPU compute technology. So we have partners working in collaboration, which creates a real unique opportunity because we're going end to end across the ecosystem.
Okay, and InfraPartners, as you said, they're, I think, described as the AI data center builder in the collaboration. So what differentiates your approach to AI-focused facilities compared with what we might call traditional data center developers?
Sure. From an InfraPartners perspective, we follow an advanced off-site manufacturing design, build, and implementation model. And we have a standard reference design model that we build to, which we now refer to as the Rapid Hub. And what that does, Philip, it gives us 80% building factory, 20% on site. Now, what that does, it means that it reduces the demand for skilled resources in locations which are always hard to source. It increases the quality because we're building in the factory. There's multiple checks and QA processes that we follow before leaving the factory so that we have minimized on-site rework. And we use a warehouse model where we are pre-building components ready to ship into multiple locations as we see that demand growth come through for us.
And the sites, as I understand it, they are relatively small. I think it's 5 to 20 megawatts. So from the design perspective, what changes when it comes to building micro data centers specifically for inference workloads rather than hyperscale training environments? Is it just shrinking everything down, or is it a little more complicated, shall we say?
It's a little bit more complicated, but if I keep it to the summary level, training workloads require huge amounts of compute, huge amounts of density, but there's less impact from an end user perspective for it, because the training workload is trained, refined again, and becomes available as a model to be consumed. What we're seeing, and as Ben pointed out at the beginning, is that we're seeing this transition into inference, into agentic, into robotic, where there is a need to have a closer footprint to the end user community for speed, for latency, for performance. And that means that we have to put in place in these micro data centers, improve resilience to make sure we can hit our performance uptime. And that means that potentially we have to make sure that the performance of the micro data center closer to the end user is more driven by the end user experience than it is from a training hyperscaler. And there's a fine line between that, because hyperscalers can cater for both in terms of large training modules and high-end enterprise compute and user experiences. But our focus starts to switch to what that AI workload will be and how that AI workload will be consumed, and that's how we build our data centers.
Okay,
and just to
sorry, yeah.
Oh, sorry, just to add on to what Bal was saying, I think a big piece of this as well is, if you look at the training data centers, these are really large loads, and the industry was really sort of surprised when these really started getting built out, and we had these just hundreds of megawatts of ramp rate in a few milliseconds. It was really a little bit problematic for the industry and stuff to understand how to accommodate that. And so I think load profile on what these inference data centers is going to look like, I think it's going to be really interesting, and I think is a significant part of sort of the effort we're doing to sort of understand that. Because the load profile for what real-time translation looks like is going to be completely different from what it looks like if you're running AI finance models for a big finance company. And we've had some hypotheses on what these load profiles were going to look like, but then as everything's changing, you bring in agents and stuff that are working at night. So now it's not just people creating workloads, it's agents creating workloads. It changes that whole mix. And so that, I think that's going to be a really interesting part of the discovery of this whole process and this whole project, is understanding what those load profiles look like over time.
Yeah, and maybe following up on that, I mean, I think it's acknowledged that AI inference still demands the high density compute that we're seeing at the moment for the large language models. But how is it possible to engineer power distribution and cooling systems to support GPU accelerated infrastructure at this smaller scale, bearing in mind that, to Ben's point, I suppose no one's quite sure at this moment what those workloads might look like?
Sure. So from an InfraPartners perspective, our standard reference design, our rapid hub design, continually follows the NVIDIA roadmap for it. So we're already designing for the Rubin GPU chipset, which is now the production release, will be the main production release by the end of this year. What that means is we have to factor in the digital infrastructure requirements from a data center perspective. So we're already factoring in cooling at 93% plus, already factoring the transition to DC power, because we know that needs to scale. And we're also factoring into the design the greater density of the rack, so the flooring is then designed accordingly. Now, we've continually aligned ourselves to the NVIDIA roadmap, so that's just part of our DNA to make sure that we can move forward in step with the GPU compute changes that are upon us.
Okay, and we think already mentioned the off-site manufacturing. I guess it'd just be good to understand or just to emphasize what are the benefits when it comes to modular prefabricated construction in terms of accelerating deployment timelines. And I guess here we're talking about these substation adjacent sites. I know that's one of the things. So is there any sort of extra benefits when it comes to that sort of modularity and off-site manufacturing?
So from an InfraPartners perspective, because we have a standard design model that we follow. We're not starting from scratch every time, so that when we get a new project, a large percentage of that design is already available to us by default. And then we customize it to the location, and we customize it to the use case that we have to accommodate. But we're not starting from a zero base each time. Now, what that does, it gives us schedule consistency. It gives us a higher quality of product because the majority of that solution is repeatable. So we're doing it time and time again, and then the QA process kicks in before it leaves the factory. Now, what that does, repeating myself a little bit here, is that it gives us schedule certainty. It gives us less exposure to regional or on-site resource demands or climate exposure, which can typically delay projects. And as we find, working with Ben and the rest of the partners, as we find these locations, what that means is our repeatability is expected to increase. So that gives us more consistency, more build in the factory and less on site. So our ramp up can then accommodate that.
And in terms of building adjacent to utility substations, I'm wondering whether either you have any thoughts as to the practical engineering or education challenges. I mean, is there anything in particular that needs to be looked at when it comes to deploying AI data centers so close to grid infrastructure, or does it make no difference whether grid infrastructure is right next door or a little bit down the road, shall we say?
From our perspective, we have an in-house design team, and we have electrical design engineers with decades-long experience that have chosen to join InfraPartners. So, in real terms, the approach, the methodology is exactly the same. Where we have to accommodate is how much available power is there for the data center. What does that mean for the infrastructure power? And how do we work with EPRI and the substation providers and land providers to maximize that footprint? So there's little change, but we do need to be diligent that we apply our design process and methodology consistently.
And if I could tag on there, I think this goes to the point of sort of the great partnership here, with all the different providers, as we look at these substations, we identify, to Bal's comment, where we have hosting capacity, where, we have power available, and then working with, Prologis and folks and understanding, where's the real estate. Is it brownfield? Is it greenfield? And I think that goes to InfraPartners, a really neat system they have available to be able to support, these different types of situations, whether you're dealing with an industrial customer that has gone out of business. And so, there's an opportunity there, or is it a literal greenfield? And it's a new build opportunity. There's all kinds of different situations in there. And it's not just power, do we have fiber? Is there gas if we need backup generators? Is there water? If that's necessary, all the different things that you need to really qualify a site. But bringing together sort of this partnership here to solve all those challenges, I think has been really great.
We see less challenges because of the skill sets that are across the organizations that have come together. We see more opportunity here because we are so close to the grid. It gives us the opportunity to create, as Ben has called out, grid-aware, behind-the-meter solutions that allow us to partner with the grid. So to start to become a grid asset, a grid contributor. In terms of the opportunities, being so close to a substation gives us greater opportunity to become a grid partner. So behind the meter solutions, being a grid partner, contributing to the grid. And our recent partnership and collaboration announced with Emerald AI, where we are looking to integrate solutions that partner with grid signals, allow us to optimize the digital infrastructure within a data center. And then longer term, as we develop the solution, we'll be looking to transition AI workloads across multiple data centers that fit this 5 to 20 megawatt scenario that are close to consumers, so that we can work with the grid when there is huge demand in a specific region. We can pick up those grid signals, and then we can redirect AI workloads to different locations, different data centers that we're building, because we're building a very repeatable model. And we'll be working with EPRI and Co to find those sites that are close to mirroring each other, or we can mirror them in our solution design footprint. And that gives us a much greater ability to work with the grid and move workloads where there is better power availability or better pricing for that window, and then move them back. So we're becoming a far more flexible partner in that context.
Okay, and overall, as I think both of you sort of suggested, the partnerships looking at creating replicable or repeatable model and talking about rapid and scalable deployment. So in terms of how much of the design, I think you mentioned it earlier, but maybe just want to expand on it, how much of the elements of the design are standardized versus site specific, and also with the repeatability, I mean, just how important is that in terms of the overall commercial success of what you're doing?
Sure. So I think I've covered it off previously, but because we follow the NVIDIA roadmap, we're very closely aligned. So we change as they change, and we adopt their solutions. And I think in terms of the commercial model, there's a couple of factors. Having the factory to site model, the repeatability is critical. But on top of that, it is the QA process. It's having the schedule consistency. Because one of the greatest challenges for all data center builders is that the scale of these things and the duration is multiple months and can be multiple years. Providing partners, clients, vendors, organizations with schedule consistency, improving schedule consistency as we collectively grow, gives people that confidence and that capability to continue their growth, but also continue our model, especially as inference and agentic comes in, Philip, and then robotic as well, because we can see the transition to closer to the user performance because of where the industries and the solutions that are arriving into the marketplace. And more of these solutions from an AI perspective will then be developed because they'll see a market for it and a industry and a capability that can provide the backbone infrastructure to deliver those solutions.
Okay, and as I understand it, you've got 5 initial pilot sites. Just your thoughts as to the long-term opportunity, what that looks like in terms of distributed AI nodes. I mean, do you think this will become a mainstream deployment, or is that the hope that it'll become a mainstream deployment model over the next, decade or so?
I think absolutely, because and there's actually a couple of different drivers here. I think that are worth mentioning. On the one hand, you've seen a significant amount of ask, from the technology partners looking for power for compute, and the list of large connection availability and stuff is getting smaller and smaller, and with longer and longer lead times for those big connections. So just from that standpoint, I think there's going to be a continuous need, and this is going to help meet that sort of continuous need. On the other side, I think and this gets back to some of our conversation at the beginning. These inference workloads are different than these, the big training workloads, and there's reasons for them to be geographically dispersed and closer to the customers, more latency centric applications and things like that. And so I think that is going to continue to drive, this sort of model of these smaller things. And actually, I think you're seeing, if you actually sort of look out down the road, we're going to see even more, compute all the way at the edge, in the household and things, even beyond this. So I think there's a huge hunger right now for compute at almost all levels and all stages. And I think this is a really neat model that helps provide a solution to providing power for those applications. And to your point, or to your question, I absolutely think it's going to be replicated. I don't see it stopping at 5. I think once everyone sees that this is possible, and is a viable product, and sort of to Bal brought up some new partnerships and stuff with folks at like Emerald AI around the software orchestration of all these, is really going to open up just a whole lot of possibilities, and I think it's going to be very popular.
And to add to Ben's point, the big drivers will be the AI workloads as they transition, Philip. Agentic, robotic, but the performance consistency. We, as a group of organizations, if we can provide performance consistency, that creates an additional opportunity window for more AI solutions or AI-based solutions. That will be reliable and consistent, because that's what an end user always demands. If we take a look at what happens to the mobile network decades ago, we see users demanding more performance, but performance consistency. And then on top of that, you had an ecosystem of apps that sit on those platforms, which become revenue generating for the whole ecosystem, but also beneficial to consumers who create their own products and solutions based on those and make life more easier for them. So we see that transition inevitable, and we see it as a long-term footprint that will be in all geographies.
And maybe, I mean, what I'm about to suggest might be going too far, but do you think that the current focus on the hyperscale campuses and the large language models, is that almost missing the point that the longer term sort of growth is in the edge, the AI inferencing, and I'm not saying the large language models are going to disappear, but presumably once all the number crunching is done, yes, there's new data, but there won't necessarily need to be the number crunching on the scale that being talked about at the moment. Therefore, I say, are people perhaps over focusing on hyperscale where they should be doing what you folks are doing and working out their approach to distributed AI, because that's going to be much bigger over time?
I don't perceive it as sort of overdone. I think what you're seeing is there's different types of data centers that are solving different problems. And there's different technical backgrounds, for why things have been done. My perception is, you're right. So are we, as we make these great models, I think we're going to make more and more great applications and use cases. And there's going to be, we're going to see a tremendous amount of new, things at the consumer level, the enterprise level that make use of these models. But my perception is I don't think that, once that's done, that the frontier, labs and things are going to quit making models. I don't think they're going to claim victory and stop. I think there's going to be sort of a continuous evolution. And so I think you're going to continue to see, need at that large scale for those training data centers, but that as they make new models, you're going to see an explosion in the need for the compute to actually like use it down at the user level. So that's at least my looking into my crystal ball.
We have a very similar view of InfraPartners, where we see hyperscalers and the solutions that we bring as these organizations working hand in glove. It's almost impossible to have one without the other, given that you're still having training workloads, but you will still have huge volumes of data sets that huge AI solutions will need to analyze, enhance, grow. And then you'll have near consumer solutions that will take the core data sets that are required for an end consumer or a retailer or for robotic. So the solutions that we build that are much smaller will take the key data sets from the hyperscalers and provide that at a much quicker performance to that local area, to that local region, because that's the way the applications will typically work, and that's how we see it. So we see both growing in parallel.
And maybe just finally, in terms of the edge, I know there's been debate about the speed it's being developed and who's owning it. I mean, do you anticipate that the hyperscalers will become I don't know, call them microscalers, where will they naturally just try and own all that inferencing real estate, if you like, and applications? Or do you think the telcos or cloud providers, who do you think's best positioned to take advantage of this distributed AI, the AI inferencing opportunity?
My personal view here is that it creates a whole ecosystem to put this in place. And we're at the very sort of early embryonic stages of what those solutions look like. And what that typically does, it creates a broad use case of opportunities that every organization will look at to see, well, which of these use cases and capabilities is our best fit? Which of these do we want to grow into? And who are our competitors and who are our parallel partners? One thing I think is for sure is that not one organization or two organizations can cover off the whole ecosystem. Being a hyperscaler, creating a nearline edge micro data center, finding land, working to find power, that is a broad capability organizations need to have, and becomes consuming from a time and revenue perspective. So typically and historically what you've seen is organizations partner with other organizations to create that solution that takes the best out of each organization to get there first and get there quicker and then grow their footprint.
Yeah, I'd agree with a lot of Bal's comments there. I think you're gonna there's I think room for everyone in this gold rush, and while the hyperscalers have definitely driven a lot of the existing demand for compute, I think you're already seeing the neo clouds and things that are have come to market. They're interested in diversifying away from just having 2, 3, 4 customers. And there's so many applications, and with Claude Code and Codex and all the great solutions that are coming out to really sort of democratize software development to some degree. I think you're going to see just a huge number of applications and different providers out there. So I don't know. I don't think any one group or small group of companies I think is going to sort of own all this space. I think there's going to be a large there's a large opportunity, and I think you're going to see a lot of different solution providers and things operate in this space to meet demand.
Okay, it's been fantastic to chat to you both, and thank you so much for sharing so many great insights about the project itself, and then some sort of thoughts about the industry more generally. So, Bal and Ben, really appreciate your time. Thank you.
Thank you. Appreciate the opportunity.
Thank you.